Welcome to The Explainer. Today, we are taking a massive leap. You know that basic AI chat where you just type a question and it types back? Yeah, we're moving way past that. We're stepping into the incredibly powerful world of autonomous agentic workflows using LangGraph. If you're looking to build an AI that doesn't just talk, but actually does things, you are absolutely in the right place.
To really get why this is such a game changer, we got to look at generation versus action. Up until now, we've basically just leaned on the generation power of large language models. You ask a question, it generates text. Simple. But agentic AI, it brings in a second, much more potent superpower. Action, also known as tool calling. This is where the AI stops just generating conversational text and actually reaches out into the real world to execute code, query a database, or search the internet.
Okay, let's dive into this. Here is our structured roadmap for today. 1. The power of AI actions. 2. The LangGraph 6-step blueprint. 3. Nodes and state schemas. 4. Edges and dynamic routing. And 5. Automating memory with reducers.
Kicking things off with Section 1, the power of AI actions, or giving LLMs hands.
Think of this as literally giving our large language models a pair of hands to interact with the world. We call these tools. And really, tools are just external Python functions. Let's say you're building a finance agent, right? You might have a function that checks a bank account balance, or maybe one that searches the web for current interest rates. By using a method called bindTools, we explicitly tell our AI model, hey, here are the exact real-world actions you have at your disposal. The AI takes this list, figures out the required parameters, and knows exactly what capabilities it has.
Moving right along to Section 2, the LangGraph 6-step blueprint, which is our core architecture.
So the crucial point here is that once you have your tools ready, you desperately need a framework to organize them. And the absolute beauty of this blueprint is its predictability. These exact 6 steps replace messy, unpredictable code with a highly reliable framework. First, initialize your model and tools. Second, initialize your graph and state. Third, define your nodes. Fourth, define the edges. Fifth, compile. And finally, execute. Whether you're building a simple calculator or a wildly complex autonomous system, master these 6 core components and you can build absolutely anything in LangGraph.
Next up, Section 3, nodes and state schemas. These are your fundamental building blocks. To really wrap our heads around how the architecture works, we need to zoom in a bit, starting with the state. Now, think of the state like a giant blank piece of white paper that just gets passed around your entire system. It's essentially a schema, a data dictionary, that flows from start to finish. If our finance agent checks a bank balance, well, that specific balance gets written down on this paper so the system doesn't forget it. It tracks all the inputs, all the outputs, and literally every single piece of information moving through your agentic AI. And you might be wondering, who exactly is writing on that paper? Well, that's the nodes. Nodes are the active workers in your graph. In LangGraph, we generally deal with 2 main types. First, you have the LLM itself. That's the brain of the operation. And the second type is the tool node, the hands. The primary job of any node is pretty straightforward. It receives that white paper state, reads what's on it, processes some action or decision, updates the state with new info, and then hands it off to the next step. And as that state gets passed around, it specifically tracks a growing list of messages. LangChain strictly categorizes these into 4 types. You have the human message, which is just your initial prompt, the system message, holding the AI's core instructions, the AI message, which captures its actual decisions, and the tool message, containing the raw data returned from your Python functions. Keeping these perfectly categorized is absolutely critical. It's the only way to prevent the AI from getting confused about who said what, and it keeps your logic exactly on track.
Let's move to Section 4 and see how this builds into a real system, edges and dynamic routing. So we take all these isolated workers or nodes and connect them into an actual workflow using edges. Edges represent the pure connectivity of your graph. They are the strict rules and defined pathways that basically just say, hey, when node A is completely finished, pass the state right over to node B. They make sure your data travels logically from a defined start point all the way through the system, right to the endpoint. But as you're about to see, we don't always want just strict hard-coded rules.
Because let's be real, a basic straight-line edge isn't truly agentic. The real magic happens right here, conditional edges. This is the intelligent routing mechanism. With a conditional edge, the pathway is not hard-coded. The AI looks at the state and autonomously decides, wait, do I already have the bank balance to give a final answer to the user, Or do I need to route this workflow over to a tool node to fetch more data? The AI is literally thinking for itself here.
And this brilliantly illustrates how an autonomous, cyclic workflow operates. Just look at this flow. The user fires off a prompt. The AI instantly realizes it needs outside data, so it triggers a conditional edge to call a tool. The tool executes its code, and rather than just stopping there, it fires the result right back to the AI. The AI evaluates that brand new tool message on the fly, decides if it needs to dig deeper with another tool, or if it's finally ready to synthesize a beautiful, final output for the user. It is a continuous, highly intelligent loop.
Which brings us to Section 5, automating memory with producers. Now, as the cyclic workflow runs, chatting back and forth with tools, we inevitably run into a major developer challenge. As the AI loops through actions, generating an AI message, calling a tool, getting a tool message back, evaluating it, that list of messages in our state is going to grow incredibly fast. And if we don't manage this well, the AI just forgets the context. So the big question is, how do we efficiently manage and retain this massive growing list of conversation history without having to write clunky code to manually append lists inside every single node?
Well, the answer is baked right into LangChain. By defining our state with a built-in reducer, specifically a function called addMessages, the system just handles the memory management for us entirely under the hood. This automated memory saver takes the initial list, looks at the brand new message, and gracefully merges them together automatically. It completely removes all that boilerplate append logic, keeps your code incredibly clean, and ensures your agent is totally stateful, remembering everything that has happened in the graph without you breaking a sweat.
So, with our memory automated under the hood, our nodes defined, and our conditional edges routing intelligently, we hit the final rapid-fire steps of our blueprint: compile and execute. Compiling serves as your absolute crucial validation check. LangGraph quickly scans through all your nodes and edges to make sure the logic actually works and there are no accidental dead ends. Once it passes that check, you execute. You simply invoke the graph with a human message and you sit back as your autonomous loop springs to life.
And there you have it. We've covered the sheer power of actions, the state schemas, the nodes, those dynamic edges, and the reducers. You now have the complete 6-step LangGraph architectural blueprint. The shift from basic text generation to real-world action is entirely in your hands now. So what kind of autonomous, tool-calling agent are you going to build next? Get coding, and I'll see you in the next explainer.